All right, ladies and gentlemen, it is time for our next math lesson, lesson 111, reasonable answers. This is going to involve estimation, and we're going to talk about using benchmarks for rounding and estimating today. So go ahead and write the I can statement in your math notebook along with the lesson at the top of the page, please. We're going to go ahead and get started. So first thing we're going to talk about is fraction benchmarks, okay? And benchmarks are nothing more than reference numbers that we use to compare, and it'll make more sense as we go through this today. So I've got a number line here and I've got a fraction, and I've got 5/8. And I want to figure out which one of these numbers on this number line, 5/8, is closest to for an estimate, for the purposes of estimating, okay? So I'm going to put down 0/8 here because I'm going to convert all of these into 8 so I can see what they look like. So if there's 0, it'll be 0/8. 1/2, how many 8s would that be? Well, it would be exactly half of 8, so it would be 4/8. And then 1 whole would be 8/8. So now I just need to ask myself, when I look at 5/8, which one of these fractions, 0, 4, or 8, is it closest to? Well, it's more than 4, so it would have to fall in here somewhere. So 5 is 1 away from 4, but it's 3 away from 8, which means it's closer to 4/8, or my benchmark fraction in this case of 1/2. So 5/8 is about 1/2. So let's look at that when we're talking about estimating fraction answers. We've got 3/8 plus 5/6. So the first thing I want to do is I want to make equivalent fractions underneath this number line here in 8ths and in 6ths. So 0/6, 3/6, and 6/6. I know that 3/8 is closer to 1/2 than 0, okay, because it's only 1 away from 4 and it's 3 away here from 0. I also know that 5/6 is closer to 1 than to half, all right? So 5/6 would be 2 away from 3/6 or only 1 away from 6/6. So it's closer to being 6/6. So my estimate is that 1/2 plus 1 equals 1.5. So my answer when I add these up top here should be about 1.5. So let's see, let's check this out. So I'm going to turn these both into 24. Okay, you could do 48 here, but I'm going to use 24 because I know 6 and 8 are both factors of 24. So I end up with 12 24ths plus 20 24ths. Okay, so when I add those together, I get 32 24ths, which equals 1 and 12 24ths, because I'm going to take my 1 whole, my 24 24ths, like I practiced with you in the last video you watched. I'm going to take my 24 24ths, I get 1 and 12 24ths. Hey, 12 is exactly 1/2 of 24. And it's 1.5. Hey, this time they're identical. Don't expect that to happen a lot, but it can happen, okay? So in this case, I know I'm right on track. All right, so let's look at a different one. This time, I've got two denominators that cannot be combined, or I can't make this one factor of 16. 3 is not a factor of 16, so what I'm going to do is I look at this, so I'm going to end up multiplying these later on to get the actual answer. So let's go ahead and get numbers that are equivalent on the fraction line. So I've got 0/16, 8/16, and 16/16. 1/3's a little tricky, okay? Because you've got 0/3 and you've got 3/3, but there really isn't a midway point for 1/3. So something that might help you is if I made the fraction bars the same length here as 0 or 1, you can see that 1/3 falls right here. That is clearly closer to 1/2 than it is to 0 way over here, all right? So I know that 15/16 is closer to 1. Again, it's only 1 away than to 1/2, all right? And I know that 1/3 is closer to 1/2 than it is to 0. So my estimate this time, because it's a subtraction problem, 1 take away 1/2 equals 1/2. So we're going to go up top and we're going to make those into 48. So 45 48ths minus 16 48ths equals 29 48ths. Now 24 48ths is exactly half, all right? So 29 48ths is pretty close, all right? So if I take a look at this right now, I'm very close to my 1/2. It's not exactly 1/2, not exactly like the estimate in the last problem, but it still gives me a good idea, all right? So let's talk about estimating mixed number answers, all right? So now we got 7 and 1/8, and we're adding that to 2 and 5/6. Here's a hint, okay? Don't worry about the whole numbers. We'll worry about those if we end up having to do some conversion or borrowing or anything like that at the end. Just worry about the fractions, okay? So I'm going to put my 6ths and 8ths on the fraction bar, all right? Okay, and I know when I look at 2 and 5/6, it's going to be closer to 3, and I know that 7 and 1/8, here's 0/8, so 1/8 is going to be somewhere down in here, is closer to 7. So my estimate should be 10, okay? Now, I went ahead and made 6 and 8 into 24, like I did in a previous problem. All right, so I get 2 and 20 24ths plus 7 and 3 24ths, which equals 9 and 23 24ths. Now, 23 is a prime number. I don't have to do anything with it, and I'm only 1/24th away from being at 10, so my answer is reasonable here. All right, I've got a reasonable answer. I'm only 1/24th away. And really with all of these, when we're using 1/2 as our benchmark, we should never be farther than 1/2 away between our estimate and our benchmark number. So this should not be below 9.5 or above 10.5. Okay, so let's look at another one. 5 and 3/10 minus 1 and 5/8. So I'm going to put those 8s and those 10ths on there again. 3/10 is only 2 away from 5/10, but 3 away from 0/10, so it's closer to 1/2. Okay, so that would be 5.5. 5/8 is also closer to 1/2. We did that a little bit earlier, so I'm going to do minus 1.5, which equals 4. So my answer here should be close to 4 when I'm done. So I decided to make a common denominator of 40 because both 8 and 10 are factors of 40. So I got 5 and 12/40 minus 1 and 25/40. Whoops, we've got a problem here. Okay, 12 can't take away 25. I'm going to end up having to borrow. Okay, so I borrowed 1, so that gave me 4 and 52/40 because I took 40 and added it to 12, and that was 52. Take away 1 and 25/40, which equals 3 and 27/40. Okay, 4 take away 1 being 3, 52 take away 25 being 27. These two numbers do not share any numbers in common in terms of factors, so that's in its lowest terms. Now it's your turn. These are the practice problems you're going to need to do. You're going to need to estimate the sum or difference by rounding each mixed number to the nearest whole number. I know it says whole number, but don't be confused, okay? That's just those are the same kind of directions you're going to see in your seat work, but that just means to the nearest. So this should be nearest to whichever half or whole number it is. So if it's closer to 3, then make it closer to 3. If it's 3.5, make it 3.5, okay? But 0, it should either be a whole number or a number that ends in half as a fraction, okay? Then you need to find the actual sum or difference, and then I need to make sure you're showing me your work. So copy these problems down as you see them. Write the words estimate and difference, estimate and sum, difference because this is subtraction, sum because this is addition, all right? And we'll go over these in groups tomorrow. See ya.